Recording in progress.
So our topic for the day is alternating current. So till now, whatever is that the content that we are dealing with is EMI till last week, where you have noticed that when a coil is rotated in a magnetic field, or when there is a flux linked with the coil changes with time, and EMF is induced. So in this case, last time, what we have noticed is, this is the expression for our flux, and followed by this is the expression for EMF, and followed by this is the expression for the effective of motion cum rotation. Right. So therefore, what we have noticed in that case is, in case if the flux changes in this fashion, this is the expression for EMF induced. This is what we have understood in our last week or before last week classes. Now we will try to see how it works. Remember, this is called an AC generator. In this arrangement, you will have strong pole pieces of a magnet. You can see north pole, south pole here. Honestly speaking, anytime this is the direction of the magnetic field. That's the direction of the magnetic field, anytime. And the plane of the coil makes an angle, 90 degrees with the direction of the field. Plane of the coil makes an angle 90 degrees with the field. Right. And hence, when you are rotating, the flux linked with the coil changes. See, remember, the coil is closed like this. Remember, this end of the coil is connected to here, and this end of the coil is connected to here. Remember, what is the EMF developed or generated across these 2 points is the same as the EMF generated across these 2 points. Right. And it follows this particular passion. Till here, any doubt? Till here, any doubt? Vatsala, till here, any doubt? Right. Now, what is going to happen? Imagine that this is the initial status of the armature. In this case, flux. What is the direction of the flux? So now it keeps rotating actually. Now it has turned through an angle of 90 degrees. You already know when flux is a maximum, EMF is 0 on the basis of this function. When flux is maximum means cos omega t is 1. Cos omega t minus 1. In all these cases, sin omega t is 0. So therefore, in this case, EMF is 0. In this case, EMF maximum. From here to here, this is 180 degrees turn. So please notice that. Earlier, SR is the arm up. Now SR is the arm down, which means from here to here, the rotation is 180 degrees. And from here to here, the rotation is 180 degrees. The total is 360 degrees. That is one full turn. Right. Therefore, now in this case, what you will notice is, for one full turn, one cycle of EMF is noticed. And in fact, this is repeated every turn. Every 360 degrees rotation will result a cycle like this. What is that you observed here? Here, magnitude is changing with time. not only magnitude, direction is also changing with time. Such as source of EMFs or such EMFs which will generate current, they also be like the same form. Okay. For example, if I am taking 1 ohm resistor, for example, across 1 ohm resistor, if you take, what will happen? Tell me, in that EMF by resistance. What will happen in that? The current also follows the same pattern. Such currents are called alternating current. Remember, the condition for alternating current is direction change is a must. Magnitude not. Some cases magnitude may not change. Like some different square wave function, for example, all the time plus e for t by 2 seconds. Thereafter minus e for another t by 2 seconds. Likewise, it keeps changing. Okay? Any doubts till here? Have you understood the introduction of alternating current? Anyone having doubt till this point? Sure. Right. Omega same as the omega of rotation of the armature. Right.
Recording in progress.
So these are the various stages involved. Various stages involved in the rotation of the armature. N number of stages involved in the rotation of the armature. That you can see here. So this will generate an alternating EMF and hence alternating current. What you are doing, right? What are you doing? Last. నీ బొంద చూస్తానా చెప్పే పాట విన్సావు రైట్ సో వాట్ ఈస్ హ్యాపెనింగ్ ఇన్ అన్ ఆల్టర్నేటింగ్ EMF or alternating current? Alternating AC అంటే alternating current ఒకటే కాదు, not necessarily alternating current, even alternating voltage also. So therefore, what is happening here is current changes in direction basically. It may change in magnitude or not, that's a different story. Where you will observe these things, you will observe these things commercially in 3 different regions. Water dams, you take Srisailam, Nagarjuna, Sagar, etc., particularly Srisailam, where water is stored and released through a special channel, where the pressure of the water rotates the armature. And because of the rotation of the armature, EMF is generated. And the EMF is standardized to household purpose, and it is transmitted through power lines, and we are receiving that. It is channelized, and whatever that the EMF generated, it is maintained a constant frequency 50 Hz and a constant voltage. It is regulated, and that is passed through the current lines, thermal power station, that we receive at substation. And again, we will, after receiving that at the substation, what will happen is we will lower the voltage, and that we will receive at home. We receive AC voltage 220 volts to 240 volts nearly, and the frequency is 50 Hz. Whereas some areas where water is not available, there are thermal power stations. They will basically use either gas or coal to burn, to heat water, and thereby converting steam. And that steam will go with high pressure that rotates the turbine. Okay, so they are thermally generated power. First one, idly generated idle power. Third one, nuclear based. There are reactors. The core of the reactors generates a lot of heat, and that heat is what we will use for converting into steam, and that steam will rotate the armature, and thereby you are using nuclear energy for rotation of this well, nuclear power. I hope you are following the process of utility of majorly alternating current is a major source for our existence. For example, you are using a battery, for example. For example, you are using digital camera. Earlier days, we used to have Walkman. Now, no one is using Walkman. Okay, now I'll take the example of a digital camera. We are using digital camera with batteries, high power batteries. What is that market? Chala energy. Brand. Yeah, small batteries. Duracell. She is a Duracell. You use some 30-40 shots of photo, the battery will get strained. To use another set of batteries, you require literally 40-45 rupees. One set. So DC is so cost. Suppose if you are using a rechargeable cells, you recharge these cells. Like for example, you will purchase 8 such batteries. While you are using 4, you are using 4 for recharging. Recharging, of course, takes some time. After the usage of the recharge, remember, hardly you will spend not more than 6 rupees to recharge. And you can use this n number of times. If I am not mistaken, 1000 recharges. Nearly. Those cells are utilized for 1000 recharges. So, okay. Now the question is, you are spending to purchase that 200-250 rupees undoubtedly on one battery. 4 batteries put together 1000 rupees. Okay. So for every cycle of charging, you may take say hardly 10 rupees, 1010 into 1000 times. You don't require every time to purchase that, no? So hardly for every cycle, if you are spending say 10 rupees is a maximum amount I said, which is impossible. Not more than 5 rupees, not even more than, it won't take 1 unit at least. It won't take 1 unit. So hardly 2 to 3 rupees maximum. So 1000 cycles. So you will spend 2000 rupees plus first time investment 1000 rupees, 3000 rupees for 1000 usages. You are spending 3000 rupees if you are using in the form of AC. You are not using AC there. Have you understood what my logic is here? Recharging the cells. Suppose you are purchasing 1000 times, then 40,000 is the cost required. 40,000 rupees is the cost required if you are using direct DC. DC is expensive. Even in our house also, what we will do, inverters, there is a motherboard, an electronic motherboard. It will convert AC to DC, called rectification. It will do rectification, and hence it charges the battery. It's a huge battery, whether you notice it or not, in your inverter, huge battery. And that huge battery gets charged while current passes through. When the external current is switched off, the same instrument will now do the reverse process, inversion, inverter. So DC to AC, AC 50 Hz frequency. Now you are using that DC part to AC thereafter. AC is cheaper and easy to transfer. Got the point? Right. So therefore, when you are using alternating current, for example, then usually what will come into picture is a three different set of values: instantaneous current, peak value of current, average current, RMS value of a current. Right. So therefore, we will take one by one. Now, majorly, first we will deal sine and cos functions only, majorly in AC, because our household anyway is running with the same arrangement, AC. Now, for example, you choose alternating current, and that is I is equal to I naught sine omega t. That is a function, AC current function, because I have shown you EMF function. EMF function is like this. So pure resistor, for example, I'm using, then I'll get current as I is equal to I naught sine omega t. Here, I refers to instantaneous value of the AC current. I naught refers to the peak value of the AC current. Omega refers to the angular frequency of this AC in radians per second. Omega radians per second. When I'm using 50 Hz, that is not omega. 2 pi times 50 is omega. Any doubt till this point? Anyone having doubt till this point, boys and girls? Boys and girls, any doubts? So now how to define average value or the root mean square value? See, average value will give a different explanation and root mean square value gives a different explanation. For example, you take AC. Now try to please understand, I am taking, say for example, a resistor for convenience. During the positive half cycle, the current goes in the direction A to B, means charge goes from A to B. Right. Suppose if I am taking integral I dt, I am speaking about the charge. And that by T by 2. That by T by 2 means how much charge is passing from A to B is what I am dealing in the numerator by the time. And this is again a current. This current is called the average value of AC. What is that? I am indirectly giving you the information. Same current, if I am passing a DC value, how much charge that passes from A to B? Remember, in T by 2 seconds, from A to B, if I am passing DC current, say X charge passed through that resistor. To pass the same X charge in the same time, the equivalent AC is what we will call as average value. That is the reason why average value is strictly used for positive cycle or negative cycle only, not half positive cycle, half negative cycle. You take half positive, half negative, what happens? Left to right, out amount charge passes, same amount of charge passes from right to left. Even you take full cycle also, same situation. So therefore, average current is strictly defined only for the positive cycle of AC. Any doubts? Any doubts? I'm asking again, do you have any doubts? No doubts? Clear? So tell me average current, what is your doubt? Yes. No, this is no, only positive side. Means current strictly flows from A to B direction only during that time. Or B to A only. Right. So it is not applicable for full cycle. Suppose you take another situation where same arrangement is taken, and same resistor is taken. But now I will measure the amount of heat generated across this. And I will measure this for n number of cycles, not one single cycle. So what is the heat generated at any instant? It is I square R power. I square R dt is the heat 0 to T by T for one cycle, and such cycles I am taking about, and divided by T. T9, in fact, divided by 1 minute. Now this is the heat generated due to AC current. So during the same time, I am passing some DC also, say for example. Then what happens? That IDC square is integral 0 to T I square R dt. You don't require R also here. T. And at IDC is under root 0 to T I square dt by T. Remember, if I am passing some DC current, say for a given time, what amount of heat generated through the resistor is some Q or H to produce the same H in the same time, equivalent AC current I am passing through, I am thus integrating that. So such a current, this is not IDC undoubted. This equivalent DC current is what we will call as RMS. Honestly speaking, RMS is to be taken over n number of cycles. N number of cycles. So when I'm speaking about an AC current, I will speak now about 4 different currents. One, instantaneous current. One, peak value of current. The other, average value of current, which is defined only for half cycle, either positive or negative. And the other, RMS value current. Remember, all your AC instrument responds to this instrument only. For example, you take an DC ammeter, if connected to alternating current, it shows nothing because the average value is 0. So in a second, it changes 50 times. You expect what is the direction of the needle to pass through. The net charge passing through in a given time is 0. So it shows 0. So you require hot wire instruments, which is measuring IRMS. So when AC, regarding AC, if I am expressing 3 amperes current AC is passing through, implies I'm speaking about what? Speaking about the RMS value of the AC. Any doubt till this point? Any doubt till this point? Any doubt till this point? Okay, so I have introduced the AC. I have introduced you the different. Now, the usual RMS value measurement for a sine function or cos function is I naught by root 2 and average value is 2 I naught by pi. This you already know. Mathematically, you can work on this. Okay, remember you are allowed to use these formulas I naught by root 2 or 2 I naught by pi under only certain conditions. What is that? What is that? Under only certain conditions. What is that? For only sine or cos of functions. If the function is different, it can be different types also, triangular type, square type, etc. At that time, you are not allowed to use this. That is the reason why there is something called form factor. Later, I will try to introduce you that form factor will decide what is going to be the fate of the AC. It usually defines as the ratio of RMS value of a current to that of the average value of the current. In fact, form factor will give you about the shape of the current. Right. Now, before I discuss this, phasor, a rotating vector, is called a phasor. Already we have done phasor concepts in waves. While you are drawing interference conditions and SHM conditions, we have used phasor concepts. For example, if I am mentioning the function for I as, say for example, I is equal to I naught sine omega t. Similarly, V is equal to V naught sine omega t. I will represent I graphically as what was shown here. I will represent voltage graphically as what was shown here. But phasor approach, this is current phasor, this is voltage phasor, and at some time T1, it makes an angle omega T1 with the positive x-axis. This is how we will introduce a rotating vector as a phasor. Any doubts on this? Any doubts on this? For example, if your situation is like this, I is equal to I naught sine omega t plus phi. Remember, in this case, assuming phi is positive, this is phi. So in the phasor terminology, we will represent the current phasor as likewise. Any delay in writing here and we're getting a lot of heat. Right. Right. Any doubts? No. You cannot apply Ohm's law for average and RMS value, but you can still apply Ohm's law for instantaneous voltage, instantaneous current. Okay. Now let us study. Now once we will go through some theory, then we will go for application. I am applying AC to a pure resistor and how it responds. Response of an AC current or how a resistor responds to an AC current is what I am dealing over here. Till here, any doubt? Boys and girls. Now I am taking a pure resistor. What is the meaning of pure resistance? This loop will not have any inductance. Self-inductance of the loop is 0. Now the question is, Now the question is, in this loop, this is the source function generator. The symbol for AC source is like this. This is actually a function generator. Function generator. Whereas for a DC, we will call cell or battery. This is a function generator whose value is given by sign. I know the only function at an instant the current is I, at the same instant the voltage drop across this is just now I said. I can use V is equal to IR if it is instantaneous. So what was my observation? I is V by R, V naught by R sin omega t, I is I naught sin omega t. It is as same as V is equal to V naught sin omega t. So what I have understood from this is the voltage phasor and the current phasor are always in same phase. Our voltage and current are always in same phase. In an AC circuit with the pure resistor. Now, let us study power. Power is defined as V into I. Remember here again, this is instantaneous power. When I'm speaking about a P over here, it is instantaneous power. Right. So in this case, V naught, I naught, V naught, I naught sin square omega t, that is instantaneous power. So therefore, the average power, if you wish to write, the average means taking average of this value. You already know integral sin square omega t dt by t. This is a standard relation. Sin square omega t can be written as 1 minus cos 2 omega t by 2, right? I think that is 0. So therefore, 0 to t sin square omega t dt by t is 1 by 2. And this can further be written as and hence this is written as VRMS IRMS. Remember, this is the case where AC is applied to a pure resistor. Any doubts? Any doubts till this time? Can you please ask me the question again? Mahalakshmi, can you answer that doubt? Why she is asking? Asra, That is not her question. Her question is, why you are taking average only half cycle when you are taking RMS full cycle? Is that the question? ఎక్కడ వస్తుంది యావరేజ్ వాల్యూ? Because I have identified 2 as root 2 into root 2. V naught by root 2 into I naught by root 2. V naught by root 2 is RMS value, I naught by root 2 is RMS value. నువ్వు యావరేజ్ టర్మ్స్ లో ఎందుకు ఎక్స్ప్రెస్ చేయకూడదు అని. లెఫ్ట్ సైడ్ ఈజ్ వి యావరేజ్ అన్డౌటెడ్లీ. I have understood your question. I will explain it. You are asking me why you took average power. And right side also average term only I have taken. Integral 0 to t by t is average of that function. Fortunately, this is not 0. But whereas only AC, the average value is 0 for a full cycle. Only AC current or only AC voltage for one full cycle, average value is 0. There is no problem here, you can take it. Power. You may ask me, how do you know? Function. The function allowed me to write. So any doubt till this point? Any doubt till this point? I'm asking you again, any doubt till this point? Sure. అవుతాను అనుకుంటున్నా. బ్లూ అదే, ఇట్స్ an experiment only. This is some experiment purpose only. That is the reason why okay. So what next is, now I will apply AC to a pure inductor. Now I will apply AC to a pure inductor. When I apply AC to a pure inductor, so what is happening over here? When I apply AC to a pure inductor, problem is with cable. I have now applied AC to a pure inductor. Again, when I said pure inductor, what exactly that term stands for? No ohmic resistance. So please try to understand, I am dealing 0 of everything here. Get the point? The problem is, down the line, 6-10 statements later, if you are asking the first question, implies your concentration is not proper at that time. But don't feel that all these things are easy, I'll follow, is repeatedly telling the same thing. Don't feel like that. You should take everything seriously into your hardcore desk. Right. Okay, you said that it is AC. You have applied V is equal to L di by dt. I can write dA as clearly V by L dt. Finally, V, I know I am the person who is operating the function generator. So I have the pride choice to select whatever the function I want. I can set cos or I can set sin. It's in my hands. So therefore, V is V naught sin omega t V naught by L sin omega t dt, and this time I is equal to minus V naught by omega L cos omega t. Integration is what I have done, boys. Done integration. If you don't believe, I'll write that step also. Integral di is equal to integral V naught by L sin omega t dt plus, please, that's all. So that gives, you may ask me why you have done indefinite integration. That's the first question. I have no idea about the initial or any situations. So I've studied this function. Now I got a function I is minus V naught by omega L cos omega t plus some constant independent of time, I suppose. What I will do is I'll take the average of equation 1 on both the sides. Nothing wrong in doing that. When I am taking average, then question me what time you would like to take the average. Yes, I would like to take the average for one full cycle. Then what advantage am I going to get by taking it for one full cycle? The left hand term will vanish. How do I know? Whatever it is, basically it is an AC current. For full cycle, suppose if it is a pure sine function, or even if it is a pure cos function, or even if it is some sine function plus some phi value, anything, if it is a full cycle, vanish. Now right hand side. Right hand side also, integral cos omega t d theta also vanish. Means the constant term must definitely be a zero. Suppose any one term among these two survives, that will be the constant value otherwise. But to my understanding, both vanished to zero. Not, yeah, ask your doubt. You raised hand, I'm noticing. No doubt? Sure? Right. Anyone else having doubt over here at this point? Anyone? You have any doubt? Ask me now. Yes.
Take average of the entire equation, right, sir?
Yes. I have taken average of the entire equation. I have taken average of this, average of this. This is a constant, it makes no difference. But issue is, this failed to zero, this will fail to zero. So obviously, constant must be zero. To convince you that the constant is zero, this is the only hope what I have. Got the point? Now I am moving to the second part. Here, omega L term is what I am getting over here. By the way, hello, you said the constant is zero. And I can write minus cos omega t in one form like sin omega t minus pi by 2. Agreed? Boys and girls. Sin omega t minus pi by 2. Agreed? Right. Yeah, by the way, what is this term that you are observing over here? Usually, V naught by omega L is the peak value of the current. And this term, omega L, represents some resistance type term. But I told you, I convinced you that there is no resistance in this circuit. I told you very clearly that there is no resistance in this circuit. So therefore, that is something like an opposition to AC current, similar to resistor, but not like resistor. So therefore, that requires a new identity. That new identity is inductive reactance. Opposition to AC, but non-ohmic. That is called reactance. The units of reactance is same as the units of resistance.
It is not ohmic.
Non-ohmic. No loss of energy because of its opposition. A spring opposes the motion of a block, undoubtedly. But what is happening over there? A transfer of energy is happening from block to the spring. Ke loss of block is counted as the gain in elastic potential energy of the spring. Any doubts? Clear? Right. Now, omega T is an inductive reactance. Now, if you observe the graph, I can confidently say that at any instant, if you are representing the voltage phasor like this, the current phasor is leading or lagging. You remember V is equal to V naught sin omega T. Okay, what about current? Lagging, undoubtedly. So this is how the current through the inductor will be. 90 degrees. Any point of time, the instantaneous voltage, the instantaneous current makes an angle 90 degrees. Then what is the power? What is the power? You can see the power here. The average power is 0. Why? So average power 0 means at some instant when the source comes to instantaneous 0 current, then the inductor drives the current in the circuit. So the energy transfer happens mutually between inductor and source, inductor and source, inductor and source. So there is no loss of energy actually. Please confirm me any doubts. Here voltage leads the current by pi by 2, that's for sure. And the instantaneous power you can see, this is how you can write the expression, or even to further modify this V naught square by 2XL times sin 2 omega t. The P average is 0. I have some graphical explanation also for this. Can you please confirm? When the current I through the coil entering at A, for example, A means I am assuming this point as A, this point as B for a while. So now when the current is entering at A and the current is leaving at B, I can see that the flux lines are like this. Right. Okay. What is happening is the material which you are using as a core of the solenoid gets magnetized and energy is established, like the capacitor charging, the capacitor plates are charged. Energy is stored between the plates in the form of electric field. Right. So during this process, you can see till T/4 time, you can see that the voltage curve, which is like this, and the current curve. What is the current curve? Current curve. Voltage curve, current curve. So voltage curve is like this. The current curve is like this. Likewise, you can notice that. So what is happening over here? Suppose if this is the current curve. This is the voltage curve. Now try to please see, this is one region where dot product or the product is negative. And this is one region where the product is being positive. And again, this is one region where product being negative. And this is one region where both are negative side, positive. So how much is the yellow area? Same is the other color area. So what does this indicates? Net zero. Got the point? Right. That's the picture. Any doubts? Boys and girls, any doubts? Any doubts? Sure.
Then power is given by the active, power is positive and is greater than 7%. Okay.
So in one stage, LC oscillations also same. Capacitor delivers power to the inductor, inductor delivers power to the capacitor. Likewise, no loss of energy in a pure inductor circuit. Only thing that you need to remember is the current lags by pi by 2 with respect to voltage, any instant. Right. Now AC applies to pure capacitor. AC applies to pure capacitor. Same, at an instant, I am assuming that the charge here is plus Q, minus Q, and this is your source. So Q by C, V naught sin omega t. Now do differentiation on both the sides. You'll get current expression. So finally, I got the current expression as omega C V naught cos omega t. This can be written as that 1 by omega C term capacitive reactance. The one thing that you need to notice in inductive reactance is proportional to omega, whereas a capacitive reactance inversely proportional to omega. Got the point? Which means this is for inductor. This is for capacitor. At low frequencies, XC is high. High frequencies, XL is high. XL is high. Low frequency XC is high. High frequency XL is high. Any doubts? Clear? Boys and girls. Any doubts? Sure. నీకు జాలి ఏం ఉండదరా మామూలుగా నేను ఇందాక చెప్పాను ఇందేం చెప్పాను ప్యూర్ ఇండక్టర్ అంటే ప్యూర్ కెపాసిటర్ అంటే ఆ లూప్ లో చెప్పు ఒకసారి ఏం వింటావు అప్పుడు ఇది ఇలా నువ్వు చెప్పావు కదా ఇప్పుడు నాకు సరిగ్గా అర్థం కాదు. అప్పుడు 3 సార్లు నేను అడిగినప్పుడు ఏం చేసావు? అప్పుడు 3 సార్లు అడిగినప్పుడు రికార్డు ఉంది కదా ఇప్పుడు దీనిలో 3 సార్లు చెప్పాను కదా, అప్పుడు ఏం చేసావు నువ్వు? నాకు ఇంకోసారి చెప్పడానికి ఇబ్బంది కాదు. నీకు 3 ఉన్నప్పుడు నేను పాఠం చెప్పాలి. అదే కదా ఇప్పుడు నువ్వు చెప్పింది. ఎందుకు అనిపిస్తుంది? తోపులు 5 నిమిషాలు కూడా వాడు నాకు అపాయింట్మెంట్ ఇవ్వటం, నేను బిజీ, నేను వెళ్ళిపోతాను తొంక నాకారు ఏం పేకలేక. ఏం చేస్తున్నారా? బిజీ కెమిస్ట్రీ సంకరాకపోయారా? దే ఆర్ కన్సిడర్డ్ టు బి బెటర్ స్టూడెంట్ దానికి. కాన్సన్ట్రేషన్ నీ ఇష్టం వచ్చినప్పుడు ఉంటే ఇంకోసారి చెప్పండి. ఎందుకు నీ అప్పుడు ఇంత స్లోగా చెప్పండి? అందుకే రికార్డ్ చేయట్లేని క్లాసెస్. రైట్. What is the significance of this thing in practical circuits? If you want to restrict a very high frequency current, just use an inductor in that circuit. For a high frequency current, inductor has an open circuit, a very high resistance. You may ask me, you can use a resistor. No, sir. Using resistor leads to heat. Whereas by using inductor, I can resist the current without any loss. On the other hand, if you want to filter low frequency, for example, use capacitor. For example, very small changes of current. Capacitor acts as very infinite resistance. If suppose DC, for example, no, there is no change of frequency at all. There is no change of frequency at all for DC. Considered to be almost zero frequency, DC, direct current. So how is the response of that DC to capacitor? What you are writing when there is a steady current, what is that you are writing in case of capacitor? Capacitor acts as a open circuit. That you can understand it from there. So that is the reason why this is called, a capacitor is called low pass filter, and inductor is called high pass. Correct ena ni rasedi? High pass filter.
Constant current is
A constant current source.
DC voltage and constant current source.
అవును, DC constant voltage capacitor ఏమైపోయింది, because there are no changes. Omega DC, no change of current. No change of current. Steady state means once it is settled, it's a constant steady current in one direction. That is considered to be omega. For omega tends to 0, capacitor acts as infinite resistance. So nothing passed through that. When very high changes are happening, capacitor acts as a pure conductor. That is the reason why in RC circuits, what have you taken? Initially T is equal to 0. In the place of capacitor, you have taken. Why? Because dI by dt is high during T is equal to 0. Whereas in all LR circuits, at T is equal to 0, when dI by dt is high, so that is the reason why we use a capacitor for a different purpose, inductor for a different purpose. Right. Already you know LC combination, how it plays, etc. Remember, there is no single question that came from LCR. One question. Manageable or not? Right. చేస్తే వస్తుందా? So అందుకనే what was my choice on that day? Saturday, that too 5-10 minutes. Investment versus returns. Right. So therefore, finally, what I have concluded is in case of capacitor, if you see, if this is the voltage phasor and this is the current phasor, which makes an angle, always current leads, I leads V by pi by 2. Pi by 2. I leads V by pi by. Any doubts? Any doubts? Boys and girls, any doubts? In future, upcoming classes, suppose I want to filter fast changes in currents. I just want to resist that. I'll use an inductor. ఏదైనా అపోజిషన్, ఎనీథింగ్ విల్ అపోజ్. అంటే ఫర్ ఎగ్జాంపుల్ యూ టేక్ ఓన్లీ ఆర్ సర్క్యూట్, యూ టేక్ ఆర్ అండ్ సి కాంబినేషన్, magnitude, the peak value of current will come down. Even if you take RC also, the peak value of current will come down. It is opposing, in fact. But till here, any doubts? Power also, the same situation. Current into voltage. What is happening to inductor? Same thing will happen to the capacitor. Only thing that you need to understand is, in one part of the cycle, source does work on the element. The other part, element transfers energy to the source. Vice versa will happen. And because of this mutual transfer, the net power is 0. Average power, actually. Sri has the doubt adugunnadu. Low frequency ki capacity contributes highest resistance. అది ఇప్పుడే చెప్పాలా? ఇప్పుడే చెప్పాలా? ఒక 3 days తర్వాత టాపిక్ చెప్పానా? పోనీ అందుకు ఆ రోజు వచ్చినప్పుడు చెప్తా, ఒక ఇన్ఫర్మేషన్ ఇచ్చాను నేను. అవునా? ఇప్పుడు అప్పుడు నేను చెప్పాను అనుకో, ఫర్ ఎగ్జాంపుల్, ఇది ఎలా సార్ అడుగుతాను. కరెక్టేనా? బట్ బేసికల్గా వాట్ ఐఎమ్ అండర్స్టాండింగ్ హియర్ ఈస్ low frequency offers high reactance. Similarly, in case of inductor, high frequency offer high inductance. AC, DC undi akkada. I want to filter AC from DC. Now tell me, what is the best choice? I can use an inductor. So through inductor, AC will pass. DC will pass. Suppose I want to filter AC from DC. Both components are there. I will use a capacitor. Through capacitor, what will pass? Alternating current will pass. Sometimes it happens in some circuit where you will have a DC component along with the AC. So to filter strictly AC from DC, or to strictly filter DC from AC, you will use these instruments. To filter AC and to pass only DC, you will use inductor. To filter DC, only pass AC, you will use a capacitor. That is the use of these properties. So I have introduced what is AC. I have introduced the average, root mean square values, and I have introduced what is a phasor, I have introduced how AC responds to resistor, how AC responds to inductor, how AC responds to capacitor. This is the basic study introduction to the chapter. Right. Then we will study some cases which are very famous in NCERT. Please go through this question. These are very famous cases of, still there is some pinkish. But when compared to the previous situation, there is some control. A lamp is connected in series with a capacitor. Predict your observations for DC and AC connections. What happens in each case if the capacitance of the capacitor is reduced? Right. This is a famous NCERT question. Usually, you will have such questions in mains, particularly theory type. For example, 2026 advanced also, they have given one theory question in the form of matrix match. Now, you have connected a lamp. Lamp refers to resistor otherwise, in series with a capacitor. Predict your observations for DC and AC connections. See, you can take like an RC circuit for DC. In RC circuit for DC, finally the current is 0. Initially the current is high. Yes or no? So on, ఇప్పుడు రిపీట్ చేయి, నేనేం చెప్పాను? There is nothing to see in the question. You are not listening the class. No, you are not listening. You would have spontaneously answered. నువ్వు చెప్పు, ఏం అడిగాను? చెప్పండి రా మీ క్లాస్.